Hey, it's Nicholas again with part 2 of space-time dimensionality in the science of consciousness. This part discusses non-relativistic space, i.e. space treated as if it's completely separable from time. Now, as you'll recall from part 1, our plan here is to structure our almost total ignorance at this point about non-relativistic space into some distinct but comprehensive categories, and then see what progress we can make, if any, by applying data and or theory to those categories to arbitrate between them. So the basic question here is, where is experience? Which you may well answer by pointing around inside your experience and saying, it's here. But this is a relative question. So if experience is here, where is the matter that participates in the creation of experience? So directly using things like location and topology, we can come up with 3 basic categories of spatial hypotheses. They're all representationalist, a term I use for any theory that acknowledges the basic two-ness of matter object and experiential image, of chair and angle brackets chair from part 1. So virtual representationalism puts experience in a sort of abstract bubble with no meaningful distance metric, for example, between the brain in a matter space and experience over here. Inner representationalism puts all experiential images in the brain close to the brain activity that encodes them, whereas outer representationalism puts those images outside the matter brain body, leading to 2 subcategories. Those where images are co-located with the objects they represent, and those where images and objects are not in the same spatial location. So in the interest of brevity, I won't go over the details of all of these today, nor will I explain any more detail my choice to focus on outer representationalism for the rest of this talk, although I will give references to some more materials on these points at the end of this part. So let's get started on outer representationalism, where we'll look at 2 co-located approaches and 1 non-co-located. Here's our first co-located model. Each experiencer has their own 3-dimensional row space. So we get 3 dimensions for each of n experiences, plus another set of 3 dimensions in black here for matter, for a total of n plus 1 times 3 spatial dimensions. Now, one objection that could be made about this type of theory is that physical dimensionality seems to depend on a biological feature, namely the number of experiences. Alternatively, of course, from a different prior viewpoint, this exact same feature could be seen as a healthy regrounding of physics in biology. So now, responding to that criticism, if it really is a criticism, we could ask, why do we even need a new set of spatial dimensions for each experience? So why can't they both, in this case, just project their images onto the 3-dimensional matter space? And then we only need 3 spatial dimensions. And then this approach could be a simple example of where each experience's row coordinatization is simply a re-expression of an R index in the matter space. But there's a real problem with that, which is why experiencer 1 doesn't see experiencer 2's images and vice versa. So there are a couple of ways to fix this. One is to assign each experiencer a sort of private channel that must have some sort of physical correlate, for example, a unique brain code matching image to experiencer. Another is to add a single extra dimension, which could be a time dimension or a space dimension, in which each experiencer and their images then has a unique location. And so then finally to our third outer representationalism. This time it's a non-co-located one, adding a 3-dimensional row indexed experiential space to a 3D R indexed matter space. So in terms of filling the possibility spectrum numerically, this 6-dimensional candidate definitely sits numerically between 3 times n plus 1, lots of dimensions, and 3 plus 1. And the motivation for it stems from the desire for a biologically plausible solution to the privacy problem, which doesn't require some exogenous mechanism to allocate different experiences, different locations in a dedicated experiencer differentiating dimension. So first off, a bit trivially, privacy is solved here if experiential subspaces are anchored in locations R sub E that can't coincide for two different experiences. For example, R sub E might be some neuroanatomical location in the middle of the brain. And then, for example, in this provocative construction I call N theory, there can be physically connective structure linking brain locations with private row locations, so that experiential subspaces kind of follow brains around like balloons on tethers. Now, you can hypothesize this kind of connective structure for 3+1 approaches as well, and there's good reason to. So without any physical structure linking experiential locations to the brain, transfer of information from brain encoding locations to distant object locations will violate locality. Although maybe that's okay for conscious experiential information transmission, but then we do get another load of complications to deal with in how we write physical law. But what will really differentiate physically connected 3+1 and 3+3 spaces in part 3 is special relativistic invariance, but we'll come on to that later. So now we've seen three different ideas, and I've touched on a few of the very many critiques, features, differences, measures that could be used to compare and contrast them. And given that we're trying to do science here, we want to arbitrate between competing theory classes using data and or logic rather than philosophy or subjective preference. So in that direction, it's well understood that gravity should be weaker in the presence of large extra dimensions, because field strength can leak out into those extra dimensions, so to speak. So if we have a theory, illustratively here, a version of N theory, in which there are large extra dimensions only near to experiences, then there's an experimental test. Gravitational field strength should also be weaker in these limited locations, all else equal. Although there might actually be other things also going on gravitationally near to conscious experiences if conscious experience itself has mass energy, but that's not something we'll be able to cover today. So let's track the context of our progress so far concerning spatial dimensions in conscious experience. We structured our ignorance into some categories, and we found one kind of gravimetric experiment that could, in principle, shed some light on which category or categories are then consistent with reality. So for the purposes of analyzing what gravimetry can actually tell us about different categories, it makes sense to bucket this plain 3D approach up with the virtual category, because both of these propose no extra dimensions at all. So obviously no extra dimension theories have a distinct gravimetric status, all else equal, namely that experience shouldn't have any special gravitational effect at all. And at the other end of the spectrum, in 3n+1, with very large numbers of extra dimensions, it seems that existing gravimetric observations could rule out this theory class or category, because it would predict extreme dependence of gravity on the number of conscious experiences that exist in the universe. Although there might be ways around this. So if, for example, consciousness isn't an emergent property of matter, then the number of experiences, we could say, has been constant since the Big Bang. So that there won't be a dimensional shift when experience comes into being. So it turns out that we could create large extra dimensional theories in the inner category as well as for outer co-located and non-co-located theories. So for example, gravimetry alone couldn't rule inner representationalism in or out, because there are both no extra dimension and large extra dimension categories in this theories in this category. And in fact, it's worse than this, because every large extra dimensional theory class also has small compactified theories within it. So if we don't observe a gravimetric signature associated with experience, what can we conclude? Nothing really about the categories, because every category has a small or no extra dimensional candidate. And if we do observe a gravimetric signature, all that does to first order is to rule out the virtual and co-located collocated 3 categories. Now, detailed observations could provide information about the number of extra dimensions, so that could arbitrate between 3+1 and 3+3 theories, for example. Suffice to say that gravimetry alone doesn't seem sufficient to decide between our structural categories. We'll likely need to examine other arbitration factors, such as locality, geometry, the structure of physical theory, and biological plausibility. Although, ideally, sort of soft theoretical explorations would lead to data-based arbitrations. So, for example, virtual and collocated three approaches need a private code for each experiencer. So that leads to a prediction that we should be able to observe for neural coding. Now, there's another route in addition to data-based arbitration. So if we agree a set of axioms, including the axiom that science must be contradiction-free, then logical impossibility could be used to disprove a theory class, although this always comes back to a form of data-based arbitration, because axioms other than contradiction-free science themselves typically depend strongly on data. So suffice to say, there's a lot more to be said and done about all of this spatial dimensionality and conscious experience topic. Here are a couple of chapters from the book, The Science We Need, which speak to those sayings and doings. So chapter 6 discusses space in terms of locality, topology, geometry, and dimensionality. It's non-relativistic space. And chapter 8 has more to say about the specific n-theoretic hypothesis, including a more general discussion of its gravitational implications and a little more about gravimetric investigations. So for now, though, we'll have to leave space there and move on in part 3 to time.